Okay, so this video is going to be on converting, evaluating, and solving logarithms without a calculator. So first things first, we have a basic rule, and our basic rule is we have a conversion, and we have a conversion between the logarithmic function form and the exponential function form. So remember that a logarithm is a exponential function, just written as a log, and the reason we write it as a logarithm is because writing it as an exponential to undo another exponential could get confusing. Okay, so let's look at that basic rule. So if you have a logarithm, base b of some x, okay, of some value, that is equivalent to y. So that right there, right, is written in function form. Remember, in function form, we always solve for y, so that's why it's written in that form. Now, if we take a look at the exponential form, okay, so basically writing an exponential form, what you need to have, okay, is that it's not going to be in function form. It's just going to be in exponential form. So in this case, right, we have it in function form because it's solved for y. But in its non-function form, which becomes b to the y power, so remember, whatever the base of the logarithm is, will be the base of the exponential, and whatever the exponent is what it is solved for, right? So it's equal to the y, and then that will be equal to x. So whatever you're taking the log base b of in exponential form is the new output. So if you take a look at this exponential form, okay, this exponential form technically is not written in function form because we have talked and discussed that function form is when something is solved for y. Well, written in exponential form, it can't be written such as a function, okay? So it just wouldn't make sense of that. Now, there's some other rules we do have to go over, okay? So an exponential function, as we talked about in a previous video, cannot have a base, okay, that is negative. So it must be greater than 0, can't be negative, and it cannot be equal to 0 either. Okay. However, we also need to talk about that an exponential function cannot have also the base be equaling to 1. So there's a couple of restrictions. It has to be positive and it can't be 1. And those are kind of the other things. The other thing you need to know is that the value of x, one of the other things we noticed when we were graphing logarithms in a previous video is we also noticed that x had to be positive. Remember when we talked about in the video that a logarithm has a vertical asymptote at y, at the y-axis. So in this case, x must also be greater than 0. So you won't have an x value greater than 0. So those are some basic rules. This extra stuff down here is helpful when we're doing stuff. So this is kind of like that helpful bit for when solving or when, doing something else. So the next thing we're going to have is mainly this video is going to cover using this rule. We're just going to be, we're going to be switching back and forth. Then we're going to evaluate logarithms based upon this exponential flip, and then we're going to solve some. So let's get to it. All right, so I got 6 problems. We're going to go through this pretty simple. Converting logarithmic function form to exponential function form. And the reason I'm putting functions there, you'll see in number 6 there, I got this D and E for a reason, and I'll explain it. So anyhow, so if we want to convert to logarithm form, we take a look at the base. The base is the base of the exponent. The output in logarithmic form is the exponent. And the value that we are saying it is of is what 2 to the third will create. So does 2 to the third create 8? And indeed it does. And there's your conversion. So it's pretty simple. So 4 is the base, so it's the base of the exponent. 5 is its exponent, so 4 to the 5th. Well, what does 4 to the 5th equal? It equals 1024. So this is how we're converting back and forth. So remember, what I'm doing here is that this is the base, and that this is the exponent, and this ends up being the answer. So those are your 3 things you need to remember. So here we go. Let's take a look at number 3. So number 3 is the base is 3. The exponent is the negative third. So 3 to the negative third, that equals 1/27. So we've converted. We're good to go. So on to number 4. So I'm going kind of quick through these because these are meant to be basic ones. So 10 is the base. It's the base of my exponential. The output is my exponent, so 10 to the 6. And what does the 10 to the 6 equal? It equals 1 million. And indeed, there you go. So on to number 5. The base is 10. The exponent is -2. What does 10 to the -2 equal? It equals 1 over 100. All right, number 6. So number 6 can be tricky because if you get stuck in and you start doing things, you might want to write -2 because that's the base, right? And you write -2 squared like such, and then you claim that it equals 4. Well, just be careful because, all right, -2 here, you can't have this. This does not exist in logarithmic form. Why does it not exist in logarithmic form? All right, so if you think about this, all right, it has to do everything with what we stated before. The base has to be greater than 0. So in this case, just remember, because the base has to be greater than 0, this one does not exist. So I just wanted to put that one in there just for you to have it. So we don't write it as the bottom part there. You don't just write it and presume it. It just does not exist, and I'm just showing you that. All right, on to the next problem. Okay, so converting from exponential function form to logarithmic function form. So here we go. So it's, again, pretty simple. So we will write log, okay, and then we will write its base. So base is 5. Remember now the answer in exponential form is what we say to take the logarithm of, and then the answer is the exponent. So we're just working our way backwards, and that it's now converted. So moving forward, 7 to the 1/2 is the same thing as the square root of 7. So if I wrote log base 7 of the square root of 7 is equal to 1/2. So again, we're just converting backwards. So just remember that this is the exponent. All right, this is the answer from the exponential form, and then this is just your base as normal. So going through, this is log base 2 of 32 is equal to the exponent of 5. So now this is just a conversion back and forth, and that's why we're going through it kind of quick. Again, it's the same thing over and over again. So 8 to the 2/3 is the same thing as the cubic root of 64. So what I'm going to do is I'm going to write log base 8 of the cubic root of 64 is equal to the exponent of 2/3. And there you go. It's just written in a different form. So the logarithm form is the function form. The exponential form is just the function form, but I'm talking about it as a function because I want you to remember exponential functions cannot have a base that's negative. So that's why I'm just saying that for this video. All right, so here we go. On to the next topic. So the next topic is evaluating logarithms. So what we want to do is we want to claim what must this equal, right? What is its value? So what is it equivalent to? So the easiest way to do this is actually to convert it to the other form. So I think of this as 4 to the what power equals 64. So what you're really checking for here is the base of 4, okay, to what exponent gives you an answer. So you have to remember this. When converting these or evaluating these, you already have what the base's answer is. So this is the base, and you have the answer. What you simply need to do is tell me what is the exponent. So remember, logarithms are exponential functions, so essentially you're solving for the exponential value, if that makes sense. So 4 to what power makes 64? And 4 to the 3rd power equals 64. So my answer when evaluating, I would write the answer is 3. So on to the next problem. So 9 is the base. This is the answer. So I'm looking for 9 to what power equals 729. And just like the first one, when I evaluate this, the answer is 3. So 7 to the 3rd power happens to be 729. Now moving on to the next one. And the next one is log base 8 equals 1 over 512. Now, because this is a fraction, I will know that my exponent must be a negative value. So 8 to the what exponent equals 1 over 512. So the answer to this is... So the answer to this problem is 8 times 8 makes 64. Multiply by 8, you get 512. However, you just have to remember that because the output is a fraction, that this is going to be 8 to the negative third. So the answer is negative 3. So logarithms are helpful if you know your exponential values. All right, let's take a look at number 24. 24 has 27, okay? A base of 27 raised to what power gives you 81? So this one's kind of tricky. And the reason it's kind of tricky, all right, for this particular base, okay, is because 27 to pretty much no power that you're aware of gives you 81. Like 27 squared, definitely not going to be 81. So sometimes these are tricky, and what makes them tricky is the base itself, all right, just remember the base itself could be an exponential form. So if I convert 27 really quick, 27 itself could be a base. So if I take this base and I rewrite it, well, what was 27? 27 is 3 to the third power raised to what? Okay, makes 81. So now here's the deal with this. Okay, now I'm thinking about 3 to what power makes 81. And what makes that a little bit simpler is because I know that 3 raised to the fourth power equals 81. So now what I'm trying to think about here is 3 times what number? So this is the tricky part. This one's a little bit harder. So we're going to have to use exponent raised to an exponent. Remember, you multiply them, okay? So 3 times what makes 4? So if you know your fraction rules, which is kind of nice, okay, 3 times 4 thirds will make 81. So the outcome of this one is 4 thirds. So 27 to the 4 thirds is 81. So I hope that helps to kind of evaluate that one, but that's without a calculator, so they get a little bit trickier. So we're going to do the same thing at number 5 here, right? So number 5, we have a base of 25. So 25 raised to what power equals 5? So what can make this tricky, all right, is that there is nothing that you can multiply 25 by to make 5. Like you can't do 1 and you can't do 2, correct? You can't do 25 squared. So if I rewrite this base as 5 squared, so 5 squared raised to what power equals 5? Well, I need this to be 5 to the first. So using my power rule, 2 times what makes 1? And lo and behold, the answer to this problem, sorry for my work here, I'm running out of space, but the answer is, when evaluated, that the answer is 1/2. So the answer to this is 1/2. And again, what we're searching for here is, we're searching for the exponent. So that's the answer. This is the base. Our evaluated answer will be the exponent that makes this value. All right, on to the last one. So the last one states it has 4, okay? So the base of 4, so 4 raised to what power equals 1 over 128? Well, if you take a look at this, and if you were to type in a calculator 4 times 4 times 4, that gets you 64, times that by 4, it makes 256. So 4 to the fourth power doesn't work, and 4 to the third power doesn't work. So again, this is a tricky one. So sometimes if you're told to do this by a calculator, just check your base. And my base in this case is actually an exponential function or value itself, which means that I can rewrite this as, very quickly, I can write this as 2 squared raised to what power? Okay, gives me 1 over 128. So now what I'm going to do is I'm going to very quickly think about 2 raised to what power equals 128. Well, I know that 2 times 2 times 2 times 2 times 2, so 2 to the 5th is 32. If I multiply that by 2, that's a 6. And if I multiply that by 2, that's 2 to the 7th power. So 2 to the 7th power will give me 128, right? So that's nice, because basically what I'm trying to figure out now, using the power rule, 2 times what, okay, will get me, now you have to be careful, because I need this to be a fraction, so my outcome must be negative. So 2 times what makes negative 7, and the answer to that is, erasing some work here really quick, okay, the answer to this is that if I were to take 2 and multiply it by -7/2, that would get me -7, okay? And there it would work, okay? So that would be my ticket. That's where I'm going for. Now, my answer is not -7. My answer is actually going to be -7/2. And if you were to type into a calculator 4 raised to the -7/2, you would get 128. All right, on to the next one. Okay, so solving logarithmic equations. So solving logarithmic equations, we continue to use this property that we're going through. So remember that the base is the base, this is the exponent of that base, and here's what my answer is going to be. So number 1 should work out to be relatively simple. So it's 7 squared equals x. And the final answer to this one is x equals 49. Now we just have to be careful when solving, because we have to make sure that our answer, remember our answer had some stipulations, and that was that the value of x must be greater than 0. So as long as it's positive, we're good. So bam, check, we're good to go. 49 works. All right, on to the next one. So you have, again, the base. So the base of the exponent is 4. Remember, the answer in logarithmic form is the exponent. And then 4 to the 1/2 equals x. So 4 to the 1/2 power, if we take a look at this, okay, so you can either recognize this in rational exponent form and convert it and know that this is just the square root of 4, or you could change the base, so 4 could be 2 squared, and if you had 2 squared raised to the 1/2, that turns it into 2 first, so inevitably x is equal to 2. And then that's my final answer, so long as it follows my rules where x is greater than 0, x is greater than 0. So because x is greater than 0, that works as well. On to the next problem. So I have log base 2 of x plus 1 equals 3. So my base of my exponential function is 2. The exponent is 3, and that is equal to x plus 1. So 2 to the 3rd power is 8. X plus 1, doing some quick mental math, x must equal 7. And because x equals 7, I'm done, because that value is also, again, follows our rules of x must be positive. Okay, on to the next one. So log base 4 of 2x plus 5 equals 1. So the base of the exponential function is 4 to the 1st power is the exponent, and I'm claiming that that is equal to 2x plus 5. Okay, so first step 1 is we're going to solve this. So 4 to the 1st is just 4, so we subtract 5, and then you get -1 equals 2x, and then all of a sudden you get x equals -1/2. Now, any other day of the week, people might look at that and say that, hey, that's wrong. So here is the deal. Okay, the x is not just the x of the problem, so you have to be very, very careful. The x in the function, okay, the x in the function means that the value of the output cannot be negative. So what this means is that if I go up to here, 2x plus 5, if I substitute in -1/2, okay, does it work? Is it okay? So here we go. So 2 times -1/2 plus 5. So again, I hope you caught what I was saying there. What's very, very important here is it's not that the answer that you calculate can't be negative, okay? It's going to be that the function itself here, okay, when you plug in this value, okay, this cannot be negative. So 2 times -1/2 is -1. -1 plus 5 is 4, and then you are good to go. So this answer checks out. So you do need to check your work to make sure you've done it correctly. Okay, on to one more example, and it's a little bit a different one. So here we go. So this one's different because it has an exponent in it, x squared. So here we go, same process though. So the base of my exponential function is 2, so 2 raised to the, again, 3rd power, so the answer in logarithmic form is the exponent, equals x squared plus 2x, and 2 to the 3rd power is 8, so I'm going to go ahead and subtract 8, and subtract 8. Now the reason I'm subtracting 8 and skipping over some stuff is because by now, at this point, by Algebra 2, this time of the year, you should realize that solving for a quadratic must be set equal to 0. So x squared plus 2x minus 8. And in this case, I can go ahead and I can actually factor this one. So factoring this one, here we go. So this becomes x and x. And then what are some factors of negative 8 that add together to make positive 2? And you can use positive 4 and negative 2. They multiply to make negative 8 and subtract or add together to make the positive 2. So here we go. On to the next one. So I get x is equal to 2, or I can claim that x is equal to negative 4. So again, what we don't want to do is you don't always just want to presume and say, hey, I did some math, I got answers, and that's correct. What we have to do is we got to go check these. So what we're going to check is x squared plus 2x greater than 0. All right, now, can it be equal to 0? And the answer is no, it cannot be equal to 0. So that means if it equals 0, it doesn't work. So as long as it's greater than 0, you're good to go. So 2 squared plus 2 times 2 is the outcome of that going to be greater than 0, okay? So is that greater than 0, which means is it a positive? And sure, 4 plus 4 is 8. So this one works out, so that one works. So now let's check negative 4. So negative 4. So if I plug negative 4 in, I square it, and I add to it 2 times negative 4. So negative 4 squared is 16 minus 8. And is that going to be a positive number? And the answer is yes. So in this case, both of these numbers do work. But just remember, whenever something, especially for logarithms, you got to remember the basic rules. Now, on the basic form of the logarithm, of the logarithmic form, you have to remember that it's saying log base b of x. So what it's claiming is that whatever you're taking the value of, this answer, okay, must be positive. So that's what it's claiming, and it's equal to y. So I want you to understand it's not the x necessarily that we're solving for that's in the problem that a lot of teachers do, including myself put. It has to do with the fact that the thing that you're taking it of must be a positive value. So if you plug in a negative number, but the thing turns into a positive, it's still okay. All right, so let's take a look at the next example. So the next example, this is our last one too for this video. So base 5, so 5 raised to the second power is equal to the square root of x plus 2. So here we go. We're going to go ahead and solve this. So this is 25 equals the square root of x plus 2. And the way you solve square roots is that we can square both sides. And 25 times 25 is 625. And that is equal to now just the x plus 2. And the last step here is to subtract 2 from both sides. So I get 623 is equal to x. So at this point, we can go ahead and we can check it if we want. But I will say to you, for this problem, I know for a fact that it does work. If you plug it back in, the square root of 623 plus 2 becomes the square root of 625, and the square root of 625 indeed is, is 25. So if we were taking a look at this at the conversion form wise, we would say, does 5 squared equal 25? And yes, we have our answer, and then we are done. So anyhow, this does work. That solution is a valid solution, and that's the end. So I hope it didn't go too quick, but I did try to talk a little bit quicker to try to keep the video down. But there you go. If you have any questions, let me know. But this is converting, evaluating, and solving logarithm and exponential type form functions. So I hope that helps. Let me know.